NASA's Perseverance rover has revealed the presence of organic molecules in some rock samples taken during its second scientific campaign on Mars, which began on July 7. The discovery was made thanks to the SHERLOC instrument in one of the most promising areas of the Jezero crater for the search for possible traces of microbial life past on the red planet. Welcome to Being Curious, and today we will talk about this very important discovery. The NASA Perseverance mission team recorded the presence of organic molecules among the samples taken by the rover during its second scientific campaign on Mars. The new samples, 4 rock cores collected starting from last July 7, bring to 12 the total of scientifically interesting specimens identified to date by the rover, which will be part of the collection to be brought back to Earth with the future NASA ESA Mars sample return mission. On July 20, the rover abraded part of the surface of a rock about 1 meter wide and called Wildcat Ridge, which was probably formed billions of years ago when mud and fine sand settled in an evaporating saltwater lake. After abrasion, the area was analyzed with SHERLOC, one of the tools supplied with the rover, indicating the presence of a class of organic molecules that are spatially correlated with the presence of sulfate minerals. Sulfated minerals found in sedimentary rock layers can provide significant information about the aqueous environments in which they formed. It is not the first discovery of similar chemical compounds on the red planet. Already in 2013, NASA's Curiosity rover had detected the presence of organic material in some rock dust samples, and Perseverance itself has already detected organic substances in the Jezero crater. The new measures, however, have aroused the interest of scientists as they come from an area where in the distant past sediments and salts had deposited inside a lake in conditions in which life could have existed. In addition, SHERLOC's analysis of Wildcat Ridge reports the most abundant detections of organic compounds detected so far by the mission. Jezero Crater, the place where Perseverance rested on February 18, 2021, is a depression with a diameter of 45 kilometers that houses an ancient delta, a fan-shaped structure born from the confluence of a Martian river and lake about 3.5 billion years ago. Currently, Perseverance is studying the sedimentary rocks of the delta, created by the deposit of particles of various sizes in the once aqueous environment. This area, characterized by a geologically very rich terrain, is considered by scientists to be one of the most promising for the search for traces of possible microbial life in the past of Mars. From an astrobiological point of view, the Delta Front exploration campaign, in which we are still today, is actually demonstrating that this place was habitable in the past of Mars, says Teresa Fornero, researcher at the National Institute of Astrophysics and participating scientist of the Perseverance mission. We found there those sedimentary rocks that we were looking for so much, rocks in which the preservation potential of possible biological tracers is very high. This is precisely because they are very fine-grained rocks, which usually accumulate and preserve organic matter very well. The first year of the mission we investigated more the floor of the Jezero crater, and we found many igneous rocks, which therefore tell us a remote story in which lava flows flowed on Mars. Continues Fornero, those rocks are also altered by water, so we discovered that, in the past, this lake contained liquid water. What we have observed in practice are organic materials, but with much lower concentrations than those we later found in the investigation campaign of the Delta Front, and as we approached it we observed a concentration of organic gradually increasing, up to even saturate the SHERLOC detector, in some cases. These measures therefore give us greater confidence in the fact that the Delta area is a promising area for the search for biological markers, precisely because the concentration of organic appears to be much higher. Fornero explains how the results obtained so far, in addition to confirming the team's expectations, help to keep enthusiasm high because we are on the right path. Confirmation, however, will only come in several years, once the samples have been brought back to the ground to conduct rigorous laboratory analyses. The samples we collected to be brought back to Earth, those from the Delta front, have organic material in a high concentration. So when they are analyzed on Earth with more sensitive equipment, it will be possible to identify this organic matter. We hope that these materials will help us to answer decisively, once brought back to Earth, to the question of whether there was life on Mars in the past. The first step in the Mars sample return campaign began when Perseverance took its first rock sample in September 2021. Along with the rock cores, the rover collected an atmospheric sample and 2 control tubes to collect atmospheric contaminants, all stored in the belly of the rover. The variety of samples already collected is very good and can provide a detailed understanding of the geological history of the region. The rover team is organizing the storage of a selection of these tubes near the base of the Delta over the next 2 months, after which the rover will continue its explorations of the Delta. We chose Jezero Crater for the Perseverance explorations because we thought it had the best chance of providing scientifically excellent samples, and now we know we sent the rover to the right. That's what we have for today. Thank you for watching this video and subscribe for more videos, and continue to be curious.